This is one numerical problem based on chapter light for class 10th. The question says there is an object. The object, which is 8 millimeter in size or height, is placed at a distance of 10 centimeter in front of a convex mirror. So if I write down the information here, we have the height of an object, which is denoted by h, which is given as 8 millimeter, and the object distance, as you know that the object is always by convention placed to the front of the mirror, and anything which is measured to the left of the pole is taken as negative. So it should be taken as minus 30 centimeter. Now, another important thing that you should remember that we do not need to convert these two in a SI unit or in the same unit. Yeah, it's important to remember that U, V, and F should be in the same unit, and H and H dash should be in the same unit. That means if you have H is in millimeter, H dash should be in millimeter. And likewise, if you have, say, U as in centimeter, the F and V should also be in centimeter. Now, we got this U here, and then the radius of curvature. So it's, let's say, for example, if I draw the diagram here, a rough sketch of it. So we have a convex mirror. Say if I make one convex mirror here. So convex mirror, as you know, has its reflecting surface curved outward. And let's say this be the principal axis, an imaginary line passing through this pole and the center of curvature. So we have this pole. Yeah. So we have this as the pole of the mirror. Let's say this be the focus, and say this be the center of curvature. Now, the object placed in front of it, you know that irrespective where is the object placed in front of it, the image will be always virtual, always erect, and always smaller in size. Now, what we have the radius of curvature mentioned here. Radius of curvature is this distance, that is from the pole to the center of curvature. And this is given here. This is 60 centimeter. And we are going to take it positive as it is measured to the right of the pole. Now, for finding the focal length, we should know that the focal length is half the radius of curvature. Focal length is half the radius of curvature. So we can say that this distance should be half of 60, that is 30 centimeter. So we'll be writing this information here. That is, we know radius of curvature as positive 60 centimeter. 60 centimeter, that is from here. And the focal length, that is F, again taken as positive, which is 30 centimeter here. Now we have to find the position of the image. Position of the image is indicated by V, that is V we have to find out. The size of the image, which is H dash. This is again our question. And magnification, that is the linear magnification by default here is M. Further, from the value or the sign of V and U, we can figure out whether the image is real inverted or virtual erect. Now over here, I'm going to apply this formula in order to find this relation called the mirror formula. So we know here, why should we go for this formula? Reason here, we know F, we know U, so we can get V here. So we'll be replacing F here with its value, that is 30. So we'll get this as 1 over 30 is equal to, this is U, which is minus 30. So it's minus 1 over 30 plus 1 over V. V is what we have to get here. Now, if I transpose these values to the other side, it is 1 over 30. If I transpose this to the left, we will get this as positive. That is positive 1 over 30 is equal to 1 over V. This is what we have to get. Now, if I take LCM, this is 2 times 2 over 30 is equal to, that is 1 over V. Now, we can reduce this, as you can see, to 1 times to 15 times. So we got the value of V here, and the V here is positive 15 centimeters. So clearly, the positive sign indicates the image is formed to the right of the mirror. So we got this V here. Now we have to find H dash. So finding H dash, we'll be using this relation, this one. So it is H dash over H. H dash is over h. So h we know as how much it is? 8 mm. So replacing h with 8 is equal to minus v, and we got v as 15. So it's minus 15 over u, replacing u with minus 30. So here you can see that these minus get cancelled, 15 one times, 15 two times. And if you do cross multiplication, we'll get 2 times h dash is equal to 8. That means h is equal to 8 over 2, and that is 4. So we got a height of the image, or the size of the image as 4 mm, right? As we know that the ratios h and h dash should have the same unit. So we got this also. Now next is magnification. Very clear. Magnification is m is equal to h dash over h. So we'll find m here. M which is h dash is 4, and h which is 8. So its ratio is 1 over 2, or you may write 0.5. Remember, this is a ratio of the similar quantities, therefore it does not have any unit. Now, finally, we can say that what is the nature. Once we got the magnification here, we can say what is the nature. As you can see that here V is positive, indicating the image is virtually erect and enlarged. Now, they're also asked to make the ray diagram. So for making the ray diagram, let's see. I place the object, and then from here, we'll be drawing a ray parallel to the principal axis. So a ray which is drawn parallel to the principal axis, as you know, it should appear to pass through the focus. Actually, the ray will get diverged in this direction, right? As if it is coming from the focus. And the other ray should be directed towards the principal focus. It is directed towards the principal focus. You should know that these lines should be a dotted line. It should be a broken line over here, right? And wherever these rays are meeting, like over here. So the image formed is, object is AB, and the image is, as you can see, this is positive. So this is A dash, B dash. And then still, again, you have to keep this thing in mind that this should be broken one, because here the image is virtual. So this is the complete ray diagram. We can show the rays also. This is incident ray. This is reflected. This is incident. And as you know, a ray directed towards the center of curvature rebounds back on the same path. Therefore, you should make an arrow on indicating in this direction also. So we completed doing all the working.